As Josefina said, I'm Juan Martin. I am Director of Technology for Mercado Libre, and I'm currently leading the Mercado Pago digital wallet. Today, I want to tell you how we have been able to greatly boost our team's productivity by leveraging a modular architecture. So most of you already know this, but since we have an international audience today, I want to give you some context. Mercado Pago is part of Mercado Libre, the largest e-commerce site in Latin America. And even though it was born to process payments for the online e-commerce site, it has been offering these services for our companies for a long time. And over the last few years, it has grown into a full-fledged fintech, spanning all kinds of lines of business, from issuing credits, debit cards, credit cards, mobile POS devices, and of course, the largest digital wallet in Latin America, already available in 7 different countries. But back in 2014, we were still mainly a payment processing site, and it was back then that a small team of developers in San Luis set out to take a little pet project. They wanted to create a mobile application for Mercado Pago, and they had no idea what the business model was going to be, and they had no idea of how to build a mobile app. So they sat down, they learned a little bit about Android development, iOS development, Windows Phone development. Thank God that one didn't last. And they were able to ship the very first versions, which had very basic features like checking your balance, sending money to a friend, or requesting money from a friend. Now, when the rest of the company got up on this, we immediately saw potential. We already knew what was going on in China with WeChat, with Alipay. We knew what Venmo was doing in the US. And we really saw some potential in doing a digital wallet in Latin America. However, these peer-to-peer kind of payments is really hard to bootstrap. I mean, it's only as useful as the number of your friends that are already taking part of the system. And when you go from 0 to 1 million users, it's really hard to get there. And even though it can be done, it tends to be expensive. So in order to get this bootstrapped, we figured out we needed to be able to provide use cases where people would be able to get value just by interacting with the system without my friends already being part of it. Without this, the single-player mode for our application. So we put together a small team of developers in Buenos Aires, and we built the very first single-player use case. What we wanted to do is be able to pay utility bills, such as water or electricity, directly from your phone. And this was a huge success. We started to see great numbers in growth, retention, engagement. We were really onto something. However, at the same time, we found ourselves with 2 different teams working on different locations on a single code base. And things started to get tricky. As any company, we sat down, we set up some processes and best practices, and we agreed on a release train schedule of once a month. However, Mercado Pago, as a big company, has a policy of go big or go home when it regards to new business lines. Having thousands of users was not going to be good enough. We wanted to go into the millions. And to do that, we needed way more than just being able to pay services in Argentina. So the team kept growing, and we kept adding single-player flows. We added cell phone top-ups. We added support to put money into your prepaid transportation cards. We got support for our mobile POS devices. And before we knew, we had about 50, 60 different developers working on different teams on a single monolithic code base. And as we were releasing once a month with very aggressive growth objectives, there was a huge cost of opportunity of missing a deadline. If a feature wasn't able to ship by the end of this month, it would have to wait a whole month before users could get it, and the effect at our annual growth rates will be huge. So there was so much pressure to get things shipped that by the end of each month, things will look a little bit like this. All developers trying to push through the door whatever they have been working on for the last month, and overnight, the number of open pull requests would spike. Our code review process would collapse as there was so much code to go over. Our CI work queue would be so long that it would take hours for it to process. And as we were working on a small monolithic code base, every time a pull request got merged, a bunch of others would find themselves with merge conflicts and having to need our developers to go back to them, rebase them, maybe do a regression test again, once again wait for CI to build, and it was insane. Almost every single release train ended up with some kind of delays, just waiting for things to be merged. And that was, of course, when things actually worked. Since the pressure was so high, not all pull requests were really up to standards. And when that happened, it was very common for us to find regressions. And some of them were really unexpected, like a change on top-ups being able to break how bill payments was working. So when this happened, usually you will simply revert the change that has introduced the regression and move on. But since we had so many merge conflicts, that wasn't so easy. Usually, reverting a pull request will leave the code in such a state that it may not even be able to compile. So we usually just put our head down and keep pushing forward with whatever we were working and try to get it to compile and ship. Pretty much all trains got delayed. And as the mainline kept frozen to be able to stabilize it, developers already working on the next release will start to accumulate new feature branches on their machines. When the mainline got unfrozen, once again, we will find ourselves in this situation. It was insane. And pretty much all our release trains crashed and burned badly. Business people weren't happy, our results weren't there, we got delays, developers weren't happy, we had lots of rework, we were really struggling to keep up with the demands and the speed the business was trying to get. Things had to change in order for us to be able to cope with it and be happy about our shops. So we sat down, looked each other in the face, and set a set of expectations as to how we were going to work moving forward. And it was really simple. It really revolved around three very simple principles. Firstly, we wanted to be able to do a release whenever we were ready. And that, of course, depended from team to team. Some teams will be ready in a couple of weeks. Some teams will require some more time to be able to ship whatever they were building. And we wanted to have independence. It was really hard for us, as the number of developers and teams involved in the application increased, to make everyone synchronize and be able to ship at the same time. Second, we wanted to be able to roll back changes in a very easy and safe manner. That way, whatever happened when we were trying to regress a release stream, we knew that we could take back a change and continue shipping without delays to the rest of the business unit. And finally, we wanted to take away this pressure of missing a release. And the only way to do that was taking down the cost of opportunity of missing a release, and that means being able to release faster. So we took our monolithic application and we tore it apart. What we basically did is we take each of the user flows and move them into a completely independent repo. And we gave full control of this repo to the teams working on them. We say, this is yours. Now you define how to merge, when to merge, which branches you want to maintain. And whenever you think you're ready, you simply publish whatever you work on as a new pod spec. And you are in full control of when that's going to happen and what's your schedule to release. We took all the core services, providing connectivity, authentication, caching, and so on, and we put them in a common cross layer, which is maintained by a team with a very simple instruction. Do not introduce breaking changes. And our main application turned out to be a simple empty shell, which pretty much has no code. It simply setups configuration in order to have everything boot up. And the most important piece of the application looks like this. We just pull in all the different front ends, all the different parts and use cases for our application, and we bundle them together. Now, when a team thinks has something new and is ready to ship, they simply publish a new pod spec from their repository, which they have full control, and they come to the main application and submit a very simple pull request, saying, I want to bump this pod spec. And if we go back, remember, these are completely independent. They have no idea of what's going on the rest of the application. So the same way I can bump a pod and be able to test a new version, if something breaks, I'm completely safe to turn back to the old version, ship it, and know it will not break, as this version has already been tested in previous releases. So we got the second point addressed. And by doing this, we pretty much got rid of all the issues with code review, merge conflicts, and made our lives a lot easier. The surface of conflict turns out to be so much smaller when you split your code base apart. Just by doing this, we were able to move from one release a month to one release every 2 weeks. And it made a world of a difference. But what's most interesting is that as we kept on scaling, we kept on adding new features. And each new feature set will be built in a separate module by a separate team with complete focus on making the best user experience they could for this flow. And this pretty much scales seamlessly. And we got to the current situation where we have over 200 developers in 7 different offices, in 6 different cities, in 2 different countries, and it just works. And by automating our release process, we were able to push these things even farther forward to our current release schedule of once every week. The very same day a new version hits 100% availability on the store, we already make available the next version to 1% of our users. We are constantly shipping new changes and features to our users, and that's massive. But without us knowing, it turned out that this was the tree that just kept giving. We had no idea back at the time, but this single decision would have lots of impact through time. In 2018, in order to bolster our adoption of our digital wallet, we wanted to make sure all users of the e-commerce site would be able to see and try out some of the features we were building. We wanted, for instance, our in-store payment solution to be available within the Mercado Libre ecosystem. And since the Mercado Libre application has gone through an independent but very similar process, we realized that we could simply take one of these modules and with some small modifications to the service layer, simply do this. And it's quite literal that even though both applications are completely different in their look and feel, the navigation, once you get to the in-store payment solution, you get the exact same user experience. You get the camera, you scan a QR code, you get instructions, you see whatever you have to pay for, select a payment method, check out, and you're done. And this is a single code base developed by a single team, only once, running on 2 completely different applications. And of course, you may notice one is using a color scheme based on yellow, and the other one is in blue. And that's completely invisible to the developer teams. As I said, the applications do some configuration on startup, and one of the things they define is what color scheme they want for their applications. So the exact same code base will paint itself blue on one application and yellow on the other. We remove all kind of overhead in able to do this, and we simply focus on working on the best user experience. But that's not it. In 2018, at Google I/O, Google announced a new feature called on-demand features or dynamic features. The main idea is you don't have to put everything together in your app, which is going to be costly and probably bloated. There are lots of features you probably don't need everyone to use or are not available to everyone, or are simply too randomly used that you don't want everyone to have by default. So you can take them apart from your main application, remove it from install time, and simply load them dynamically whenever the user really needs it. The idea is really neat, especially on Android, where people actually have problems with how much space they have on their phones. But the main issue with this is you need to carve out whole feature sets in able to load them dynamically. But it turned out it was already free for us. Not only that, but absolutely all feature sets were already done this way. So we were completely free to decide which ones we wanted to load dynamically and which we didn't. And moving forward, we're starting to look into what a smart POS would look like for some of our high-end merchants. And of course, those merchants will probably have very different use cases from those consumers using their mobile phones to pay on a daily basis. but some of them will be shared. And we figure we can simply create a new container application, decide which modules we want to import or not, and reuse 100% of our code base. In hindsight, this turned out to be the single most impactful decision we ever made. And it's quite shocking to me. Back when we decided to do this, people didn't talk about modular architectures. Actually, it didn't even have a name back then. For us, it was, hey, let's build a model for the app. And even though nowadays there are some conversations going on, they tend to focus on maintainability benefits of having a loosely coupled application or smaller code base, or one of my favorites, actually being able to test your application quicker by not having to wait for the whole application to build, simply building your module. And of course, these benefits are absolutely real. I mean, we see them every day. But they are really, really strict and not as impactful as being able to scale your team from 6 developers to over 200, being able to add features and gain the level of flexibility we have been able to attain by leveraging this.
So anyone has a question? There. Let me see if there is another one.
Hi, I have this question. When you start separating the models in different repositories, you start building as a project or as a framework. And what was the main issues that you have to face with Cocoa Pods?
Okay. Yeah, they're exposed as frameworks. And the main issues, well, there were plenty, especially when we started adopting Swift. For instance, until not so long ago, we couldn't import them as static frameworks. Having so many modules really impact our load times on the user devices. That's something that we could only really fix earlier this year. But other than that, it was pretty seamless.
Another question here.
Hi, Juanma. One question. I imagine you have some support libraries that are common for all the modules. How do you handle different versions of, like, different modules having different versions of those support libraries?
Okay. So as I said, we do have this core cross-services layer, which is maintained by a single team. And it does happen that since not all frontends upload new versions every time, they are referencing the same version. But that's the only one team that has a strict restriction, and they are required not to introduce breaking changes. So we will usually ship the latest version, knowing that whichever build against previous version will still build, and that's usually safe. Every now and then, we do need to do some breaking changes. We try to avoid them as much as possible. We tend to simply deprecate stuff and document the new way to do that and wait 6 months to a year before we remove the old code, giving everyone plenty of time to catch up and adapt. But when that need arises, we do have some special trains where we have to go through all teams, make sure they are ready, and do the housekeeping of making sure everyone is really there the day we release the bump version.
Great. We have time for one more question. Anyone? There it is.
Hello. Thank you very much. My question is about, first, how you define the surface level in which you decide if something goes to one feature or another, and how do you manage to do with duplication, or if you need something shared, but maybe it's not so big to take it to a module?
Okay. As for the scope of each one of the frontends, it's pretty much based from a business point of view. They tend to be aligned with different use cases and business models, like in-store payments is one, top-ups is another, and it tends to be very, very clear where something should go. As for the repeated code, it may happen every now and then, even though we have shared libraries that provide pretty much all that you are going to need. It does happen every now and then that two teams are trying to build very similar screens or something of the sort, and we're okay with that kind of duplication. We are not so comfortable when it's a whole user flow. For instance, the checkout flow where you will see what you have to pay and choose your payment method is basically the same for in-store payments, top-ups, bill payments, and plenty of other flows. So those ones are actually taken apart to cross libraries shared by everyone and are therefore subject to the same restrictions of not breaking stuff from release to release. But other than that, it's part of the trade-off we're okay with. There are some minor duplications, but it keeps things flexible and easy to maintain.